And hi, everybody. This is Slooh.com. I am Geoff Fox, your host, and tonight we are live with you for the Camelopardalis meteor shower, but also a setup of exactly why we're here with this meteor shower, why this meteor shower could be a big deal, especially across the northeastern United States and Canada. And by the way, for our Slooh members who are with us tonight, please hang out in the clubhouse during the show. Post any comments or content that you may have, and we will look at it and use it on our webcast tonight. Meanwhile, we're joined by meteor astronomer Peter Jenniskens of the Seti Institute. Peter is the guy who first speculated that this fairly obscure Comet 209P linear could produce tonight a major meteor shower. Some people say possibly a meteor storm. And I'm joined tonight by Bob Berman, who is our Slooh astronomer. And Bob, you have a lot I know you want to ask Peter tonight.
Yes, exactly. Because Peter is my favorite meteor expert in the whole world. And in And it's just amazing that he was the one who predicted that Earth would slam into the material from Comet Linear. He was first. Other meteor experts later got on board and said, yep, it's going to happen. And so to have Peter on board with us tonight is just very, very special. Our first show, of course, is going to deal with the comet. Later on, when we get closer to the actual time of the meteor shower, we're going to switch gears and focus on the meteor shower. But nonetheless, while we have Dr. Jenniskens here, we've got to talk meteor shower.
And by the way, Bob, also, that is a live image that you're looking at from one of our Slooh telescopes in the Canary Islands. And right toward the center of the screen, you're not seeing it extremely well now, but you will over the next few minutes. That is Comet 209P linear.
Yeah, we've got the culprit. We've got the comet responsible, and then later on we're going to have equipment that's going to bring in the meteor as well. But without hesitation, let me ask Dr. Jenniskens, what made you decide that this meteor shower is going to happen tonight, a brand new meteor shower?
Yeah, well, we'll have to see if it does, of course, happen, but this event has incredible opportunity. What we're looking at, a Comet 209P linear, is your garden variety Jupiter family type comet. People think it's somewhere between 2 and 4 or so kilometers in size. What's exceptional is that this object is coming closer to the Earth than any comet since 1983, Eris-Raaki-Alcock, and before that, Pons-Winnecke in 1927. So this is a really great, rare event for a comet of this sort to come this close. And that means, of course, that the people who study comets get a really unique chance to study this object. You can do radar observations, do really good imaging. But for the meteor astronomers among us, it's a very cool thing, because it means that we are basically, as planet Earth, making a comet mission. We are coming close to one of these objects, and we potentially get a chance to study the debris that the comet shed in the past as meteors in our atmosphere. And of course, that only happens if that debris is exactly in the Earth's path at that time, and that doesn't always happen. For example, Comet Eris-Raaki-Alcock, when it passed by in 1983, did not cause an unusual meteor shower because its trail of dust did not cross the Earth's path at the time. But this comet does, and that's what makes it really exciting.
Well, as I understand it, the closest the dust will come will be 19,000 miles. Now, that's close enough, in other words?
No. The closest the dust comes is 100 kilometers. It's 60 miles up. That's
I
when it
see.
hits the Earth's atmosphere, and it will briefly glow as a bright streak, and you can see it as a shooting star. The calculations talk about where does a particular trail of dust end up passing by the Earth's orbit, and what is a dust trail? It's basically, if you think of the comet passing by the sun, in this case every 5 years, the comet will ooze out some dust while it's evaporating ices in this case, for example, or when the comet breaks. It generates dust, and that dust initially hangs around the comet really as a cloud. It's really very close to the comet itself. It moves on its own orbit around the sun, but it moves along with the comet. And but when the dust starts moving out, and as the comet does, towards the orbit of Jupiter, as far as this comet orbit goes, then at some point it will fall back to the sun. This dust will come back. And what happens then is that some of these dust particles make a shorter orbit, and those particles come back early, and other particles continue on for a little while longer before falling back to the sun, and those come back late. So what was initially a cloud of dust, after one orbit becomes a dust trail. And it's basically a stream. Think of a sort of a river of dust passing by the Earth's orbit. And it's these rivers, these streams, these dust trails that we are excited about, because if one of these streams is in the Earth's path at the right moment, we get to see a meteor shower. Now, these trails are constantly moving relative to Earth's orbit, because each dust particle has its own perturbations by the planets, and so the trails wag in and out of Earth's path. But if everything comes together and the trail is in the Earth's path, then you get to see a meteor shower.
Now, Peter, what do you think are the chances of something more than a meteor shower, an actual meteor storm?
Well, because the comet is so close by, the comet itself is so close by the Earth at the moment, we are having a really interesting situation, and that is that a lot of the trails that could have been generated in the past, if the comet was active in those years, are now concentrated in space in a very small area. Really, all the trails from the 18th, much of the 18th, 19th, and early 20th centuries are all piling up very close to Earth's orbit. And that's very unusual. And then the big question is, was this comet active in those years? And we do not know, because this comet was only discovered in 2004. And it's a weakly active comet. It's not one of these comets that carries a big waving flag and you can see from a big distance. This comet is actually hard to spot. So it was only discovered in 2004, and we do not know what it did in the 19th century or the 18th century. But the cool thing here is that it is this type of comets, these weakly active Jupiter family comets, they seem to be responsible for many of our meteor showers. And they do not do that by oozing out water vapor and creating this nice comet tail that you can see in the images. No, they do that by periodically massively falling apart by fragmentation events. When we look at our meteor showers, and I'm talking about showers like, for example, the Alpha Capricornids in July, or the Quadrantids in January, even the Geminids in December, big showers, beautiful to watch. Those showers were created in these sort of sudden events where a lot of debris was generated, and we see typically about as much mass in the stream as there is in the comet itself that's left over. And so these are rather disruptive events, and it looks like that's the way these weakly active Jupiter family comets predominantly lose their mass. And that means that's the way we are getting our zodiacal cloud. It's this type of phenomenon that creates the band, the light band that you see sort of next to the Milky Way on the sky. all the scattered sunlight from dust particles in a solar system. So this type of comets are really interesting. They are hard to spot. They are difficult to watch because they don't do a lot, but they periodically do really a lot. And so it's really interesting to have an opportunity to look into the recent past of such a comet. So
Peter,
we don't know what this comet did in the 17th, 18th, or 19th century, but who knows?
Peter, this is Geoff. Let me ask you to connect some dots for me here. You're with the Seti Institute, and for those who don't know, that SETI stands for Search for Extraterrestrial Intelligence, and
Yes.
you're looking at meteors. So
Yes.
connect the two for me. Why would someone who's looking for extraterrestrial intelligence look at meteors?
Because people looking for extraterrestrial intelligence are interested in all aspects that have to do with how life got started on our planet and how it may have gotten started on other planets and what life has to endure and how life can survive. So meteors, comets, these asteroids play a big role in bringing the ingredients to our planet that were necessary for life to originate. The carbon atoms in your body, much of the water in your body, came from comet impacts that happened a long time ago on our planet. And it's interestingly enough, it's the comet you're looking at, 209P linear. It's that type of comets that we think that the Earth was bombarded with at the time, and they brought in the material that you and I are made out of. And so it's a really interesting. We're really very connected to space in that sense.
And what we're looking at on the screen right now, by the way, are some images of meteors that we're seeing that we think are connected to 209P linear that were seen earlier. We never thought that this would produce real annual shows, but now that we look back, maybe there's some evidence that this comet has produced meteor showers in the past, Peter?
Yes. So we have never detected a shower on May the 23rd that comes from this recent dust ejecta. But if you look very carefully to meteors coming in, and we are doing that with a video surveillance here in the California, San Francisco Bay Area. We have boxes of video security cameras set up at 3 different locations. We film the night sky, we detect the meteors, and then we triangulate their paths and calculate the trajectories and the direction from which they're coming. And that way we are mapping the meteor showers in the sky. And if you look at that data and carefully, you can find weak showers that seem to come from this comet. And one of those weak showers we picked up in the second week of June, called the Sigma Ursa Majoris. We only picked up a handful of the meteors, but they move in the almost the same orbit as 209P linear. They come in the same way in the Earth's atmosphere. And this video is a compilation of some of those meteors from our cameras, and it really gives a good sense on sort of what these meteors might look like in the sky. They're very slow moving meteors. They only come in at 19.4 kilometers per second, which is a fraction of the 60 kilometers per second that the Perseids come in the summer. So instead of getting these swift streaks in the sky, we expect, meteors gliding through the air. It's stately motions, and so and the meteor should be coming from a northern direction. So, if the shower shows up, if there will be a shower tonight, it's going to be just for a couple hours when the Earth is traveling through this debris cloud. So you have to really be there at that correct time. And then what you should be seeing is these slow-moving meteors. Even if you see just a few, you'll be the very first person to ever see these. And so that's very exciting.
Well, if we're the first, Bob Berman here, if we're the first, can we expect future linear showers when Earth returns to the same spot in our orbit every year from now? Will we hit this stuff again?
Yeah, that's a really interesting question. this is never going to be ordinary. This is never going to be an ordinary shower, because this is not going to be an annual shower like the Perseid or the Geminids, for example. But it turns out that this comet has evolved really interestingly. So initially, for the recent past, it has passed well within Earth's orbit. We were never in a position to cross these dust trails. But this year, for the first time, we actually get a chance to cross that debris. And so it is pure coincidence that now happens just with the comet being that close to the Earth. So this is quite incredible. But if you look at the future evolution of the comet orbit, you can see that the comet is actually staying with us for a while. So every 5 years, the comet is returning and it's passing by the Earth's orbit. And until 2044, it will continue to pass relatively close by Earth's orbit. And there will be more opportunities to see some of these dust trails. But we're never ever going to have this situation again where there's a whole massive pileup of dust trails right in the Earth's path. Because we're never going to be in this position again where the comet itself is really close to the Earth.
Fascinating. Now, are the particles, again, one more question, Bob Berman, back with you. Are the particles, you originally thought that they would be, or they could be larger than usual comet particles, and therefore the meteors could be brighter than what we normally see in a meteor shower. Would that be true, and do you still think so?
Well, I never said that, but I can comment on it. So my colleagues have investigated the dust that the comet ejected in the previous return in 2009 and in the return of 2004 when it was discovered. And if you look at that dust, then it does appear that the debris is relatively rich in larger particles. Now, what does that mean? Does that mean that you're going to get fireballs? Probably not, because for these slow meteors, you need a pretty big chunk of material to be able to get a bright fireball. You really it's really kinetic energy you're seeing as light. Okay. And so for slow meteors, it's not that easy to get really bright meteors to appear. But what it says is that the meteors may be tilted towards the brighter side, so that for a given amount of brighter meteors, you won't see as many faint ones. And what that does is it makes it a hard radar target. So it's not an easy shower to observe by radar, but it's a really cool shower to observe by your naked eye. And so, and video cameras and so on. So we'll see.
Very exciting.
Well, Peter, I know that you wanted to be able to get out and do your own observations this evening, so we're going to let you go. But yes. Thank you so much for your time, and on behalf of all of us who'll be looking skyward tonight, thank you for making your theory that tonight could be a special night known to all of us. I think mostly discoveries like this are sort of languish in the scientific community alone. This has become something that people outside of astronomers are going to be looking at tonight. And that's your doing.
Me and many others, but I think so. It's really a great exploration, a great investigation to be part of. I mean, who knows what we're going to detect? If we don't see anything, it will tell us. It gives us information too. It will tell us that the comet in those years was dormant, was not active. If we do going to see something, we're going to carefully measure it, and we're going to try and determine when was this comet active and how was it releasing debris at the time. And I'm very happy that my institute, the Seti Institute trustees, has given me a chance to go up in a small aircraft with a small group of people, and be at altitude to see this meteor shower. So tonight, just 2 hours before the peak of the shower, we hope to take up in the air, and we then hope to be above all the dust in the lower atmosphere, and then have this really nice view of the
dust in the upper atmosphere.
The lower atmosphere. You want to be above the crowd.
But I'm saying you'll be able to see the dust coming into the upper atmosphere.
Exactly. Yes, exactly.
Well, thank you so much for joining us, Peter. I hope your trip tonight is a valuable one for you.
Thank you.
Thank you so much. Okay, that's Dr. Peter Jenniskens from the Seti Institute. He is among the folks that have postulated about our meteor shower that should be seen tonight. Later on, we'll talk more about that later. What you're looking at on the screen now are some meteors that have been linked to Comet 209P Linear, which is the comet that is responsible for this meteor shower and that Dr. Jenniskens has been talking about over the past few minutes. Let me set this up for those of you who are just joining us. This webcast is brought to you by Slooh.com. Slooh.com is an astronomy community. Among other things, we get amateur astronomers together to talk about a hobby that they are incredibly passionate about. We maintain 3 excellent telescopes, 2 located in the Canary Islands, 1 located in Chile, all located in great locations, high up above the dust, above lots of the atmosphere, where you can really see well. These are available to our members who send the telescope on missions every single night when the skies are clear. And get the results via the internet. It's a phenomenal organization and a phenomenal opportunity, especially if you are interested in astronomy. If you'd like to find out more, if you'd like to join our community, head on over to our website at slooh.com. We're having an introductory membership offer right now where you can get 3 months of Slooh membership for $29.95, which is a 60% saving. But more than anything, for $29.95, you can see if Slooh is for you. And if you are interested in astronomy, if you would like to have a really fine telescope at your disposal at a good location where the ambient light is low and the skies are clear, this is for you. So please head to slooh.com. Bob, we're going to show in just a couple of minutes a little video about asteroids and about Slooh's participation with the Asteroid Challenge. But let me just ask you this. When you listen to Peter Jenniskens speak about this, you hear right away, yes, he's a scientist and all, but this is a guy whose science is based in his own passion for what's going on, isn't it?
Of course, yes. Almost all of us in the field are doing it not for the money, but because we love this and love the universe.
And the comet that we're looking at now, the comet that's responsible for this is a pretty dim object, isn't it?
Yeah, it's about 11th magnitude, and for a comet that is so close, Peter Jenniskens mentioned that it's only 1 to 3 miles in width. He used kilometers, but that's what it amounts to. And
right.
It's the 3rd closest comet we have seen since 1927. I remember comet Iris-Araki-Alcock. It was quite visible, quite bright back in 1983. So it's amazing to have a comet this close. It's only 5 million miles from us to be as dim as it is. So it's a very, very small comet.
Also,
yes,
you and I were talking earlier, the possibility is it's also an old comet, and so it's gotten rid of a lot of its dust over the years.
Yeah, every time a comet comes in, it loses more of its material. In fact, we think that meteor showers such as the December Geminids, which in that case was caused by a body named Phaethon, which we think is an asteroid. Well, is it an asteroid? Is it a comet? Meteor showers come from comets, but it acts like an asteroid. It doesn't have a tail. So more and more thinking is that old comets, what's left of them, a little tiny rocky core, and you're left with something that we might call an asteroid. So there's not much left to this comet, even though it was first discovered only in 2004 by the Lincoln Near-Earth Asteroid Research Facility.
And that in and of itself is very interesting. The Lincoln Near-Earth Asteroid Research Survey is an automated, ongoing astronomical observation program. Can you tell me a little bit more about it?
Yes, increasingly, rather than people looking for comets, and the Japanese in particular were famous for it, as we look at some images of Comet Linear just taken recently over a 1-hour period, more and more there are automated research facilities that are looking at the sky, and if it sees anything new, well, it'll be the first to report it. And comets are the last objects, Jeff, I think you know this, that bear the name of their discoverer. If you find a new galaxy, or my goodness, if you found a new planet, it would not be named Jeff. It would be
It should be, though.
it should be, but it wouldn't be. So the final objects in the universe that are named after their discoverers are comets. So unfortunately, or fortunately, more and more, rather than bearing the names of people, we just mentioned Iris Araki Alcock. Well, Iris, back in 1983, was an automated research facility, and so is the Lincoln Near Earth Asteroid Research Center. So Linear got its name for it. They used a 39-inch scope, not terribly much larger than our Slooh instruments, and that's one of the reasons I think a lot of Slooh members are hunting or tracking asteroids and comets, because we certainly have a large enough telescope to do that.
Yeah, and actually, we had Peter Jenniskens on a couple of moments ago. He and some of his students were out at the Nubian Desert looking for remnants of an asteroid that had come into the Earth's atmosphere. As it turns out, that was 2008 TC3, and Slooh members had been looking at that. In fact, among the few amateurs able to see it.
Yes, that's right. It's a lot of fun when you actually get a find or a fall. Now that's an object. Now the Chelyabinsk intruder from February 15th of last year, famous, exploded over Siberia, left behind pieces. And I know somebody who has just bid on, and he has successfully bid on it, so he's going to acquire a piece of that. So when you actually see an object and then can get your hands on it and display it in your living room as a meteorite, well, that's even more exciting.
Well, we're going to talk more about meteorites and meteors, and talk more about what's coming up later on tonight, which is this what could be a bust, or could be a major meteor shower, or even meteor storm. It's called the Camelopardalis meteor shower, and we are hoping, though so much of this is always up in the air when it comes to meteor showers. There's so much that we don't know. There are so many simultaneous equations that have to fit in for these to work. We do want to tell you, though, a little bit about something that Slooh is participating in, and that is the Asteroid Grand Challenge. This is a NASA program, and we're very excited because NASA has come and asked our Slooh members to participate, and this is what it's all about.
So the next large asteroid to hit us is likely going to hit us without warning, and it isn't because we don't know how to deflect the thing. It's because we're not looking for it.
We've seen the damage even a small asteroid can bring.
We know there are a million objects out there that could hit the Earth that are bigger than Chelyabinsk. So we have to figure out the best way to find them.
Which is where Slooh comes in. Slooh is partnering with NASA in their Asteroid Grand Challenge. In the past, our members have imaged asteroid Apophis, Toutatis, and many others. And we're back live from Slooh.com tonight for a couple of occasions. First of all, for Comet 209P linear. That is what we have on the screen, though, quite honestly, I believe it's a little bit above the center of the screen, in the center left to right, and we'll get better pictures as we go through the night. We've had some excellent imagery from our Slooh telescope located in the Canary Islands. And we're also going to be talking about, and we'll be back on later with hopefully the camelopardalids meteor shower, which is predicted for tonight. Meanwhile, though, we're joined right now with Jason Kessler from NASA, and he is the program executive of the Asteroid Grand Challenge. Jason, it's a big name, Asteroid Grand Challenge. What exactly is it?
Well, hello, Jeff. It is a big name because it's a big challenge. And the challenge statement is to find all asteroid threats to human populations and know what to do about them.
Now, we're talking about things like Tunguska, like the February asteroid in Siberia, larger things. These mostly come to Earth unnoticed?
Chelyabinsk was a surprise, and the timing was so unusual. We knew that DA-14 would be passing within the geostationary satellite belt, and all attention was on that. And lo and behold, from the sun, or from the direction of the sun, comes Chelyabinsk. And unfortunately,
you can't point your telescope at the sun.
Nope. We wouldn't have known it was coming even if we were looking that way. So $40 million in damages and roughly 1,000 people put into the hospital, and that was only about a 17-meter asteroid.
So let's talk about how amateurs can get involved in this, because I think most people would think that, isn't NASA covering all of this by themselves?
Well, we didn't announce the Grand Challenge because there was this impending threat. We announced the Grand Challenge because we recognize that there's an incredible opportunity given the network connectivity, the computing power, the level of global education, that this was the kind of problem that we felt like engaging with citizen scientists and using crowdsourcing means we could potentially accelerate the work NASA's already doing. So NASA's found, that, real quickly, I'll say that NASA's found
please.
98% of the planet killer or 1 kilometer or larger sized asteroids, but there are a lot out there that get down to 30 meters that we're not clear on where they are and what their orbits are. And so we're working very diligently with our global partners as well. But there is an opportunity for amateurs to contribute, whether it's improving algorithms in the surveys, telescopes, as one example, whether it's doing light curve analysis or characterization of known asteroids to get a better understanding of their shape and their spin rate. These are things that are really helpful for us. And so that's really what's behind the Grand Challenge.
And these are things that we think that our members can help with our Slooh telescopes. I mean, these are within the realm of what a well-equipped amateur could do, right?
Yeah, in fact, this is why I was so pleased to see the Slooh proposal in our request for information that we issued last summer, and to be able to review that, have a presentation at our workshop, and then to be able to finally announce our Space Act agreement where NASA and Slooh are working together to deal with this issue, because you already have members that are getting scientific papers published for the asteroid work they're doing.
So what will amateurs be bringing you? They're going to look at or produce light curves that shows us what the rotation is on the asteroid. Is that right?
Correct. And so one of the challenges in terms of characterization, the NASA effort has really been focused on detection and better orbit determination. And so that's where our money has gone. And because that's what you do first. We need to know where they are. Because of the way the survey telescopes work, currently there isn't a whole lot of opportunity for them to do follow-up or any real characterization work. And that's where there's an incredible opportunity for amateurs who have the wherewithal to spend an evening, potentially multiple nights in a row, taking images over a longer period of time so that we can get the variation in the reflected light off of that spinning asteroid. And that kind of information gives us its rotation. And there's some folks in Europe that are then turning that information into actual shape models. So the ability of the amateur community to come and support the professional survey work and deliver good characterization is a tremendous benefit to all of life on planet Earth.
Yeah, that's pretty amazing that they're working on doing shaping with ground-based telescopes, because wasn't that mostly done by radar or space-based telescopes in the past?
Correct, and that's what we do. We have Goldstone as well as Arecibo at our availability when we believe that there's an asteroid that is close enough and worthwhile imaging with the radar, or believe that its orbit is a potential threat. We can flash it with the radar and really get incredible characterization information. You can see beautiful video of the response to that radar imaging. But because it's can be challenging, we can point Goldstone, we can't point Arecibo. The ability of using amateurs that have scopes all over the world and happen to be in night potentially when we need to be taking the light curve imagery, it's pretty exciting to think that data can then be turned into some reasonable shape models.
And for Slooh members, by the way, we invite you to go to our clubhouse at slooh.com, and this is a members only part of Slooh, and bring up the discussion and start talking about it and start getting together so some of you can actually form your own teams to work on the sightings. What you would like to make, what you would like the missions of our telescope to be, so we can reacquire some of these asteroids and help out. Is there I'm asking a question that I know the answer to. Let me ask it differently. What is the website for the Asteroid Grand Challenge, and is that where people can go to find out more?
Yeah, so the first place to visit would be www.nasa.gov/asteroid initiative, and that will take you to the NASA site that has information both on the Asteroid Grand Challenge as well as the Asteroid Redirect mission, which was the mission we've been working on to go and capture an asteroid, redirect it to a lunar orbit, and then ultimately send humans into a deeper space to go grab samples from that asteroid. So there's great information on that site. And then
the crazy part to me, Jason, with that is so many people say it's going to be easier for us. We already have the technology to redirect an asteroid. Where we're short is being able to know exactly where they are.
What I think we're really excited about with regards to this mission is, and part of the tagline with the Grand Challenge is to prove that we're smarter than the dinosaurs, because 66 million years ago the dinosaurs had a pretty bad day. And if only they had a space program, they could have potentially averted disaster. And so with one option in the asteroid redirect mission, where we would go to a larger asteroid and pluck a boulder off, we'd be actually able to demo outside of the influences of Earth's gravity what a mitigation solution in terms of slowly dragging an asteroid off its course would look like. And so that's fantastic, because right now in terms of mitigation, we can do models and simulations, but we don't have any proof that it would actually work. And so the other site that I'll direct folks to is AGC, that's Asteroid Grand Challenge notes.wiki, W-I-K-I, spaces.com. And that's a place where we're gathering ideas. It's kind of a conversation where folks can share their ideas on how we might be doing this grand challenge better.
And of course, for our Slooh members, we're inviting them to also join the conversation in our clubhouse. Jason, tell me why you chose to work with Slooh.
Well, beyond what a great guy Michael is, after having the pleasure of meeting him, and I have to say it is a fantastic job that he and the whole crew at Slooh have done for these past 10 years, building this incredible network. The willingness to reach out through the RFI that we had released and propose and then present after being selected to participate in the workshop, recognize the real commitment that Slooh brings to this work. And I can't think of a better example of what the Grand Challenge is really looking to do. We are looking to engage as broadly as possible a community to help with the effort of resolving this Grand Challenge. And so recognizing that the Slooh community was already doing asteroid work and getting papers published, we were so excited to be able to partner with Slooh in this Space Act agreement to help spread the word even more broadly and hopefully get more of your members excited about doing asteroid work. Because one of the challenges with asteroid work is that it can be hard and it does take time, and it's not necessarily for everybody, but it's of such great import that we thought that the Slooh model is a perfect way for us to make some early wins with this grand challenge.
And it's sort of amazing, because now we can have these great telescopes that we use, like our telescopes in the Canary Islands, which, by the way, for those just looking and wondering what's on the screen, that's a live view from our Slooh telescope in the Canary Islands. And just to above the center of the screen, in the center, left to right, if you look closely, you can see the tail of Comet 209P Linear. That's the comet that is responsible for the meteor shower that we expect to see later this evening, and we'll be talking about that more. But that image is coming live, or actually nearly live, from the Slooh telescope. I say nearly live because it takes a little bit of time for us to process that image and bring it through. This is not something that we take a snapshot like with a camera. We need to bring lots of photons in there before we can show you something on the screen. But this is the comet that is responsible. Well, Jason, I want to thank you for this tonight. And the folks at Slooh are very much looking forward to helping and looking forward to helping advance what we know about asteroids. And I guess this is a very immodest thing to say, maybe even helping to protect the Earth in some small way, because asteroids certainly have the ability to make it not an extremely pleasant day.
That's right. And one of our other mottos is survival is its own reward. And And I think that the Slooh network and the incredible membership you have can really join us on the front lines of addressing this problem.
Thank you so much. Thanks for joining us this evening.
You bet. Thank you, Geoff, for all you do.
Okay, thanks, Jason.
Okay.
And I'm back with Bob Berman here on Slooh, and tonight is a very exciting night for us because Comet 209P linear, and that, Bob, what you're seeing on the screen, that is just a phenomenal image. That's crazy beautiful. We're talking about a comet here that's around magnitude 11. It can't be seen with most amateur backyard scopes, but for the Slooh telescope tonight, this is just incredible. Can you give people an idea what exactly we're looking at there in the center of the screen?
Yeah, we're looking at a comet that's almost at its very closest to us. It has a 5-year orbit around the sun, and it is only 5,150,000 miles away. It's actually going to be at its very closest a few days from now. Now we're talking about about 6 days from now, but it's just about at its closest now. And to see it and know that material from this comet shed in the 18th century, 19th century, early in the 20th century is what we're going to plunge through. Our planet is going to collide with this stuff in a few hours from now, producing an unknown meteor shower. We're all used to the summer meteors every August 11th. Maybe we watch them in summer camp. Some of us who are more into astronomy watch the Geminids every December 13th. But a brand new meteor shower, now that doesn't come along very often. This is a once-in-a-lifetime event. And to see the comet responsible for it, the material that's going to come from this, that's what Slooh is tracking tonight.
It's very tantalizing because there is the hint. Now, there's never a guarantee with this, but there is a hint that this could be more than a meteor shower, that it could actually be a meteor storm. And there are recorded instances of meteor storms, right, Bob?
Yeah, the last true storm was on November 18th, 1966. I interviewed two of the people who saw that, one fellow on guard duty in the military, another woman in a train in Texas. And what we were seeing then was 60 meteors per second that lasted for the better part of an hour. 60 a second, all radiating away from a section of Leo the lion, and everybody who saw it thought the world was coming to an end. It was Armageddon. What else could it be? Then the same parent body, a comet named after the famous astronomer Edmund Halley, reappeared in 2001 on November 18th. Many of us got to see not quite a storm, but 5 bright green shooting stars per minute, 5 a minute. And that was the last time there was anything that surpassed our normal summertime Perseid meteor shower. Now, tonight, something like 3 a minute, could be 5 a minute. And so for many people, anyone who has clear skies tonight, they should go out. If you don't, or if you're in a city, definitely stand here at Slooh with us. And even if you do have clear skies, check us out, because we'll show it to you and we'll give you information about it. This could be the best meteor shower of our lives. On the other hand, it's the first time ever. And as Peter Jenniskens said, you never know for sure. So the uncertainty is part of the thrill.
Well, let's talk a little bit about why we're here for just a moment. This broadcast is brought to you by Slooh.com. We're a community of astronomers, of amateur astronomers. And what brings this community together is our discussion boards, our website, and certainly our 3 telescopes, 2 located in the Canary Islands, 1 getting set to come back online this month, located in Chile, all 3 in just phenomenal locations for the internet. If you want to find out more, go to our website, poke around a little bit, or maybe you'd like to try an introductory membership. What that does is it'll give you 3 months on Slooh, you'll be able to set the telescope on your own missions, look at whatever you want, whether that be a star cluster or a galaxy or a planet or an asteroid, because as you heard a little while ago, we are participating with the Asteroid Grand Challenge, or a comet like 209P linear, which is what is showing right here, right now. It is our members who steer the ship. It's our members who decide what the telescope is looking at on any given night. And by the way, for our members, if somebody else has set up a mission, our members can share in the imagery from that. We have high quality imagery in the proper format that is supported by most software that's used for astronomical observations. So you will be set being able to really use the information, use the data you can get from Slooh in the best ways possible. Check it out at our website, slooh.com. Again, the introductory membership offer to get your feet wet, $29.95 for 3 months. Bob, let's talk a little bit about tonight's potential meteor shower. After I've just spent all this time talking about the telescope, we're going to have to say that really a meteor shower is not a good event for a telescope. It's a naked eye event.
Yes, it is. Very much so, Jeff. Of course, with the Slooh equipment and partners, we'll be training the equipment at a part of the sky, and meteors that come by will show up as streaks. So we will be able to access that for people who are not in clear skies. I would urge anybody in North America listening who has clear skies tonight, if you're away from the lights of a major city. If you're not, if you're in a city and you have a car or friends with a car or friends in the country, well, get going. It's a Friday night. You don't have to work tomorrow. Drive out, and 2 o'clock Eastern time from 2 to 4, check it out and see what's happening in the sky. There could be nothing. There could be a few meteors a minute, or it could be the best meteor shower of your life.
And the best thing to do is just go out and lay down and look up. Even though this meteor shower emanates in the northern sky, the truth is the meteors can be anywhere in the sky. The radiant point just means that if you traced each and every one of them back to where it originated, they would come to one point. But where they burn up in the sky could be anywhere above you.
So true, Jeff. That's absolutely true. So you could really face any direction, and one of the tricks is just to keep your eyes glued to the sky. Some people, just out of habit, hang out with their friends, and they're looking at their friends and just glancing up from time to time, and that's a sure recipe for missing almost all of them or all of them. Keep your eyes
or to
glued
hear
the
somebody
sky.
say, "Did you see that?" You don't want to be the one who's listening when somebody says, "Oh my God, did you see that?"
Yes, exactly. So if you have clear skies, and especially if you're not in a big city tonight, or if you can get out of the city, give it a try out between 2 and 4 a.m. Eastern time. We're going to be here. We're going to be covering this thing and narrating it, and we're going to start at 11 o'clock Eastern time, even though that's before the main shower begins, but we'll have a lot to talk about.
Yeah, that's 8 o'clock Eastern, 5 o'clock Pacific. That's 3Z, 3 UTC. So it will be late this evening across most of North America, and overnight for those of you who can watch us from Europe. And if you're in Europe or Asia and the sun is already up, please join us and watch at slooh.com, because we will be back on for that and to bring it all to you. Let me get back here to what we're looking at. Bob, a meteor like 209P linear, how common is something like this? It's not very bright. No one would be able to see it with the naked eye. Are there objects like this in the sky every night?
Almost every night. Comets that require binoculars or telescope or Slooh-level telescopes to see, there's almost no time that there's not some comet around. So it's not all that rare, and it's only every 15 to 20 years that we get what's called a Great Comet. And great means bright enough to be seen with the naked eye over city lights, even.
Like
And
Shakataki.
exactly, there was Yakutaki, there was Hale-Bopp. We're going back to Comet West in 1976. Some would say Ira-Siraki Alcock back in 1983. There's not many of them. Those are kind of rare. Where since the last one is now. Let's say 15 years away, we're sort of due for another great comet.
Let me ask a question that people who will be looking tonight may be confused about. All of us have seen the video from Chelyabinsk of that great fireball in the sky, and then the sonic boom and the windows exploding, and obviously people getting hurt. And we're going to look up in the sky tonight, and if this meteor shower shows up as we hope it will, you will see also bright lights in the sky. But none of these will make it down to the ground, will they?
No, quite right, Jeff. And that's because Chelyabinsk was a house-sized object that burst. And first of all, it was an asteroid, and asteroids are made of sturdier stuff. They're stones or metals. And this fragment from a comet are ices, and these are far more fragile. They never become meteorites. You know, you can gather pieces from an asteroid that passed by, like the famous one on October 9th, 1992, that destroyed a woman's car in Peekskill, New York. And the 10-pound intruder, well, she sold that to a collector for $69,000. It's kind of not necessarily bad news. Only one person in human history has ever been injured by a meteorite. This one came through a roof and harmed a woman, Ann Hodges, in 1954 in Alabama. So nothing to fear. And these are skimpy ices that will all burn up before they even reach 60 miles up, far above where the highest jetliners fly. So no danger at all.
And what you've been looking at, by the way, are some time-lapse photography of this comet responsible for tonight's meteor shower, 209P linear. Our Slooh members have been imaging this for a while now. This is a comet that was originally discovered. Bob, when was it? Was this discovered in 2000? I'm trying to look at my notes.
Yeah, it was discovered February 3rd, 2004. Again, by the Lincoln Near Earth Asteroid Research Facility. And although it wasn't originally recognized as a comet for what it was, after all, it's very small, only somewhere between 1 and 3 miles across. It was originally given the name 2004 CB, which is not a comet type name at all. But then when it was restudied and reacquired in December of 2008, then it got its present name of 2009 P, as in Peter. But the real name, I mean, here's one of the rare cases where we don't have to use license plate type designations. We don't have to say 209P. We can give it the real name, Linear. That has, especially considering some of the comets we've had, like Yakutaki, hard to pronounce names. So Linear is nice and easy to say. Comet Linear. And it's so small that even though it's quite close to us, it requires our good Slooh telescopes to image it at all. So I think the real spectacle for us is not how the comet looks, but what it will do when pieces of it smash into our atmosphere tonight.
And of course, we anticipate this happening. As you can imagine, throughout history, for the most part, these have come unexpected and unnoticed, except for the most famous ones. Most of these have just appeared out of the blue. Well, we'll be back tonight at 11 o'clock Eastern Time, 10 o'clock Central, 9 Mountain, and 8 here in the West. That's 3 UTC. We will have some full sky cameras for you. We will have as much imagery as we can put together. We know, unfortunately, that much of the Northeast is going to have cloudy skies. Same thing from the Dakotas down through Kansas, Nebraska, Oklahoma, and into Texas. There are going to be cloudy skies. Here where I am in Southern California in Orange County, we expect the marine layer, what they called down here, Bob, the May Gray, will be forming, and that probably will limit our ability to see anything from here in Southern California. So the best place to see it will probably be from us at Slooh.com. So we'll see you back here with Bob starting again at 11 o'clock Eastern Time. That's 3 Universal Coordinated Time at Slooh. And we will end.